Welcome to the Explainer. Today, we're tackling the AWS SAA03 certification exam, and to really make sense of all of this dense material, we're going to frame our entire analysis around building a digital skyscraper. Think about it. To construct any massive, resilient structure in the cloud, you absolutely need mastery over two foundational pillars, your compute and your storage. So by the end of this, you'll have the complete Architect's Toolkit required to leverage Amazon's Elastic Compute Cloud, or EC2, and the simple storage service, S3, to build some truly highly scalable architectures.
Okay, let's take a quick look at our mental roadmap for today. We'll start with the twin pillars of AWS. Then, we'll dive into EC2, the compute engine. Third is securing and paying for EC2. Fourth, we'll look at S3, infinite object storage. And finally, we'll wrap up with S3 optimization and storage classes. Let's get right into it.
Section 1. The twin pillars of AWS. Building your digital skyscraper. Mastering the interplay between our active processing engines, that's EC2, and our highly durable vaults, S3, is literally the bedrock of becoming a successful AWS architect. You just can't design a functional digital skyscraper without understanding exactly how the machinery talks to the filing cabinets.
To ground us, let's look at a core definition. EC2 is essentially the ultimate example of infrastructure as a service, or IaaS. Think about the old days. Instead of buying, racking, and maintaining physical hardware in some freezing, incredibly noisy server room, IaaS lets us just rent raw, virtualized machinery in the cloud exactly when we need it, and, best of all, release it when we don't. It's a total game changer. Moving on to Section 2, EC2, the compute engine, the machinery of your cloud skyscraper. This service is what handles all the raw processing power, the heavy lifting, the actual execution of your architecture. Think of it as the literal engines driving the elevators and the day-to-day operations of your skyscraper.
Now, when you're renting this machinery, you've got to pick the right tool for the job. General purpose provides a really great balance for simple things like web servers. Compute optimized, that's for your high-performance batch processing. Memory optimized gives you massive RAM for in-memory databases. And storage optimized gives you huge local drives. And hey, quick pro tip for the exam, when you launch these, you'll often use IAM roles to securely grant them access to other AWS services. Oh, and if you need hyper-low latency between them, you can group them together using EC2 placement groups. Now, you definitely don't want to be manually configuring this machinery every single time you spin it up. That's where the magic of the EC2 user data bootstrap script comes in. Instead of manually using SSH via PuTTY or EC2 Instance Connect to log in and, say, install an Apache web server, you just inject a simple bash script at launch. When the instance boots up for the very first time, it runs that script automatically. Bam! It's ready to go from second one. All right, Section 3, securing and paying for EC2, firewalls and financials. Now that we've got our compute engines humming along, we really need to lock the doors to protect them. And just as importantly for an architect, we need to optimize our monthly AWS bill. So, EC2 instances are protected by security groups, which act as virtual firewalls. But there is a huge, absolutely crucial contrast here. Inbound rules are blocked by default. If you want web traffic, you explicitly have to open port 80 for HTTP. But outbound rules, those are authorized by default. Traffic leaving your instance can go pretty much anywhere. This specific difference is a highly common exam trap, so keep it securely in your mental toolkit for test day. We also need to route traffic to these engines, right? Well, standard public IPv4 addresses on EC2 are ephemeral, meaning if you stop and start your instance, AWS just assigns you a completely different IP, which totally breaks your app. To fix this, AWS offers elastic IPs. These are static public addresses that attach to your instance's virtual network card, which is known as an Elastic Network Interface, or ENI, and they stay fixed even through a full restart. Okay, let's talk financials. It can be kind of a dry topic, but this vivid hotel analogy really brings it to life. Think of on-demand pricing like a walk-in hotel guest. You pay the highest possible rate, but you get ultimate flexibility. Reserved instances are like signing a 1- or 3-year lease. You commit the time in exchange for a massive discount. And spot instances, that's literally like bidding on an empty room at the last minute. It's incredibly cheap, but the hotel can kick you out the second a higher-paying guest arrives. Comparing these options side by side, we can really see how this plays out for an architect. On-demand is perfect for unpredictable workloads. Reserved gets you up to a 72% discount for steady databases. Spot instances offer up to a staggering 90% discount. But remember, AWS can abruptly terminate them. So they're terrible for critical databases, but they're fantastic for resilient batch jobs, especially if you group them into a spot fleet to maintain high availability. Finally, dedicated hosts give you physical servers entirely for your own use, which is an absolute must for strict regulatory compliance. Moving right along to Section 4, S3, Infinite Object Storage, the vaults and filing cabinets. So that's our compute. Let's transition over to the second pillar of our skyscraper, moving away from the active processing engines and down into the vaults and infinitely scaling filing cabinets of Amazon S3. S3, or Simple Storage Service, is your object-based storage. You store files, called objects, inside of buckets. Now, while the bucket name you choose actually must be globally unique across all of AWS, the storage itself is highly regional. And here's a fun fact. There are no real folders in S3. It just uses long key paths with slashes to trick you into thinking there are. Oh, and if you ever need to upload data globally from users around the world at crazy high speeds, you can use a great feature called S3 Transfer Acceleration. S3 is astonishingly versatile. We're talking massive data lakes, disaster recovery, and even static website hosting. You can easily host a static HTML front page directly out of a bucket. Though, to be clear, you can't run a dynamic server-side backend directly from S3. But what's really amazing is that S3 is an active service. You can use S3 event notifications to automatically trigger a Lambda function the exact moment a new file drops into your bucket. But security-wise, here is the crucial point to remember. When you create a bucket on day one, it blocks all public access by default, and every single object you upload is automatically encrypted. Literally nothing is exposed to the internet unless you actively uncheck the safety blocks and write a specific IAM policy or an S3 bucket policy to intentionally grant that access. Which brings us to our final part, Section 5, S3 Optimization and Storage Classes, Managing Data Lifecycles. Let's look at the final tier of the Architect's Toolkit. How do we keep our data highly available, safe from disaster, and yet aggressively optimize our monthly AWS bill? Well, we start with data protection. S3 versioning protects you from accidental deletes. Instead of wiping a file permanently, S3 just hides it under a delete marker that you can easily restore later. Pretty neat, right? S3 replication allows you to asynchronously copy objects across entirely different regions for high availability. But actually, here's the architectural catch you need to remember for the exam. Enabling replication absolutely requires versioning to be enabled on both the source and the destination buckets. By default, your data sits in S3 Standard. It gives you millisecond retrieval, but it is the most expensive tier. As you move down through the storage classes to infrequent access and then way down into the Glacier Archive tiers, your monthly storage costs get remarkably cheaper, but retrieval times jump from milliseconds to literally hours. If you don't know your access patterns, S3 Intelligent Tiering is a fantastic class that just automatically moves data between tiers for you based on usage. It takes the guesswork right out of it. Because let's be real, you don't want to move all that data manually. S3 lifecycle rules allow you to completely automate the flow of objects through those exact storage tiers. For example, active thumbnails start in standard, they transition to infrequent access on day 30, hit deep archive on day 90, and automatically expire on day 365. Just beware of this little caveat. Lifecycle rules can move data down into Glacier, but they cannot move data from Glacier back up to standard. Before we wrap up, I want to leave you with a golden rule for aspiring architects. Always protect your wallet by performing section cleanup. If you simply stop an EC2 instance or use EC2 hibernation to pause it and save your memory state, the compute charges stop, but the storage bill attached to it just keeps ticking. You must fully terminate unused instances and clean up resources to prevent a massive shock on your invoice. So, here's my final thought for you to ponder. As an architect building your digital skyscraper, how will you balance the raw, scalable power of your EC2 compute engines against the long-term, compounding costs of your infinite S3 storage? Mastering that balance, well, that's the true art of cloud architecture. Take these tools, apply them to your designs, and keep building.